Hello, welcome everyone. Today in GCSE we are starting quadratic equations. So let me see what exactly quadratic equations are and by what methods we can solve it. Let me explain quadratic equations from the very basic. Suppose I'm writing x plus 3 is equals to 4. Obviously, if there is an equals to sign in between it, that means it's an equation. And if there is a variable and a constant, that means letters and the numbers, that means it's an algebraic expression. Quadratics are the algebraic expressions, but we have to distinguish it whether they are linear quadratics. How will I get to know it? By the power over your variable. In this equation, x is your variable, your letter. And what's the power or the degree over it? That means x to the power of 1, x to the power of 2. Clearly, I can't see anything over there. So don't assume it to be x to the power of 0 because I teach students live online. And what the problem I found that they think that if there is nothing over x, it means x to the power of 0. Well, let me tell you, if you know the exponents, you know that anything to the power of 0 is always 1. So x to the power of 0 is 1, not x. So x is x to the power of 1. Clearly, if it's x to the power of 1, it's a linear equation. And if there is no equals to sign, so I can say it's a linear expression. Then if I increase the power from 1, if I'll go to 2, highest degree of this equation is 2. So I can say this is a quadratic equation because the highest degree is 2. Let me see the standard way of writing a quadratic equation. It's ax squared plus bx plus c equals 0. Ax squared plus bx plus 0, that means this a, b, c are constants and can take any value. That means it differs from equation to equation. In some equation, you will find a as 2, b as 1, c as 3. It depends on equation to equation. And x is a variable. That means the value of x can vary from equation to equation. AB are also known as coefficients. The numbers that are written with the variable are called coefficients. So A is a number. As I told you, A, B, C are constants. That means it will be a number. If a number is written with a variable, we say it's a coefficient. So A is a coefficient of x square because A is written with x square. And B is a coefficient of x. Whereas C is not with any variable, so it's just a constant. So suppose the equation is given as 4x squared plus 3x plus 9. If I have to compare it with the standard equation and I want to know what is A, what is B, what is C, I can clearly see A is 4, B is 3, and C is 9. Ax squared. A is a number written with x squared. Clearly A is 4. Bx. B is a number written with x. Clearly it's 3. And C is any constant which is not written with any variable. It's 9 here. Similarly, if it's x squared minus 9, what's the number written with x squared? There's no number. So it's not a 0 because 0 multiplied by anything is 0. It's 1 actually. Wherever, just like x to the power of 1, we don't write 1 there. It's just x. Similarly, 1 times x, we don't write it as 1 times x. Instead, we write it as x squared or x. A is 1 here. If I go to compare it, I'm not finding any x here. So I can say B is 0 and C is negative 9. Or if it's 3x squared plus 4x equals 0. Again, on comparing, I'll find A is equals to 3 because A is a number with x squared. B is a number with x, which is 4. And there's no constant right here. So apart from 0, so C is 0. So this is how we can compare. This is very important. Whether I'm solving it with any method, ABCs are very important. So let me see by which method we can solve quadratic equations. First is factorization method. Second is completing the square. Third is quadratic formula. Fourth is graphical. They are all very important. Quadratic is that topic which is not only specified to quadratic, you will find it incorporated with the other topic as well. Suppose I say linear equations, x plus 3 equals 4. This kind of equation I can find at the end of ratio as well, at the end of algebra, finding ages. We can find it anywhere. Similarly, quadratic is also a part of many different topics where end result, where you have to find some values, you will find this equation. Even in probabilities, you will also find some questions where after solving all the things, suppose the question is find the number of red balls. Then after doing all things, you will find a quadratic equation in here. So quadratic and linear equations or algebraic equations are those equations that are not only a separate topic, but you will find them incorporated in different topics as well. So I'm starting with the factorization method that we see, and one by one we'll be completing each and every method. Factorization method, as the name suggests, it's about finding the factors. We have to find the factors, then it would be very easy for us to find the answer. Take the example x squared plus 4x plus 4 equals 0. If I compare it with the standard equation, I'll find a is equals to 1, b is equals to 4, and c is equals to 4. Now in factorization method, I have to find two factors, because one thing you have to keep in mind, in linear equations we have seen it's x plus 5 is equals to 7 suppose. If I solve it, I will get only one value of x, and in this case it's 2. As the degrees changes, that means the power over the x changes, the number of solution changes as well. Here the x to the power of 2 is there. Degree is 2. In this case, you will find two different values for x. It can be real, it can be imaginary, but still you will find two different values for x. So this is the reason that we will find two different factors, and that's why we have to assume two numbers. So we have to find two numbers that their sum should be equals to b, and product it should be equals to a into c. In this case, b is 4, so sum should be 4, and a is 1, c is 4, product should be 4 as well. I have to find two different numbers. When add up will give me 4, when product will give me 4, it's very easy, it's 2, 2. So what I have to do is, there is a small trick, a short trick, but don't repeat it with every another type of quadratic equations. Again, I'll say, because I teach students and I know what kind of mistakes they do. They think that this is the method so they can apply it everywhere. It's just a short trick. Wherever you will find a equals 1. In those equations, whatever the value you are finding for two numbers, directly you will write them in the factors. In this question, we found that the two numbers when add up to will give me 4, when product will give me 4 are 2 and 2. So I'll make two factors like this, and I'll write x plus 2 and x plus 2. That means x squared plus 4x plus 4 can be written as x plus 2 and x plus 2. You know, expanding the double brackets, you can open, you will find again x squared plus 4x plus 4. That means it's a way of writing it in a factor form. Since the product of these two factors is equals to 0, that means either one or both numbers can be 0. Either this can be 0 or this can be 0, and we don't know. And that's why x1 plus 2 equals 0, x1 is minus 2. And similarly for this bracket, I'll write x plus 2 equals 0 and x2 is equals to negative 2. So my two answers are, though they seem to be very similar because they are, but still we will write it as x1, x2 and negative 2 and negative 2. Now coming back to the one point that I was telling you, this is applicable only where a is equals to 1. There you can directly write this. But if a is other than 1, 2, 3, 4, 5, then this short trick you can't apply. Let me do some other questions. X squared minus 5x plus 6 equals 0. Now in this we have to think two numbers. Their sum should be equals to b, which is minus 5, and product should be equals to a into c, which is 1 into 6. Some important things that you have to keep in mind while selecting the two numbers. First thing is always start with the product. What's the product? If your product is positive, it means first number and second number both can be positive, both can be negative. Then we have to look out the sum. Product is positive, it gives me idea that both are positive, both are negative. But which case I have to pick depends on the sum. If sum is negative, that means obviously both numbers are negative. If sum is positive, that means both numbers are positive. Now comes the next, when product is negative. When product is negative, it means one is positive, one is negative. But how should I know that which one is positive, which one is negative? Depends on sum again. If sum is negative, that means the larger number is negative now. Because minus 6 plus 4 is what? Negative 2. Why? Because 6 is a larger number. And what's the sign of 6? Negative. That's why you will get negative 2. So what's happening here, when one is positive, one is negative, you will always subtract it. Always subtract it. Don't add it. Keep in mind, if one is positive, one is negative, you have to subtract. And which sign will you use? The sign of the larger number. If sum is negative, it clearly gives me idea that larger number is negative, smaller number is positive. If your sum is positive, it means larger number is positive, smaller number is negative. Just like 6 minus 4. 6 minus 4, 1 is positive, 1 is negative. 6 is positive, 4 is negative. Answer is subtracted. And which sign will I use? The sign of the larger number. 6 is a larger number, so 2 will be having the positive as well. Okay, coming back to the question that we were doing. In this case, product is positive. That means I have these two possibilities. Both numbers can be positive, both numbers can be negative. Sum is positive. If both numbers are positive, it's not possible to have a negative answer. It means obviously both numbers are negative. So I have to think two numbers. Their sum is 5 and product is 6 and both numbers should be negative. That's why the sum should be negative 5. Again, if I want to find, I have to start factorize 6 and simply it's 2 into 3 into 1. So there are two ways. 3 into 2, 6 and 1. Either I can get 6 and 1 as my answer or 2 into 3 into 1, which is 2 and 3. I have two numbers, 6, 1, 2, 3. Since I know both numbers are negative, so minus 6, minus 1 can be one possibility. Minus 2, minus 3 can be one possibility. If I add them, minus 6 minus 1 will give you minus 7. Minus 2 minus 3 will give you minus 5. So the two numbers are minus 2 and minus 3. X squared minus 5x plus 6 as x minus 2 and x minus 3 equals 0. From here, x1 is equals to 2 and from here, x2 is equals to 3. We'll get two different values for x. Now, I'm taking one example where you can't apply this short trick. 2x squared minus 5x plus 3 equals 0. Here, a is 2, b is negative 5, and c is positive 3. A is not equals to 1, so we can't use that method. We have to go conventionally. Even that question where a is equals to 1, you can solve with this conventional method as well. But that's a shortcut. We have to do the same thing. We have to find sum of two numbers that should be equals to b, which is minus 5. And product should be equals to a into c, which is 2 into 3, that is 6. So it's the same kind. Sum is minus 5, product is 6, that is two numbers are minus 2 and minus 3. So this is also known as splitting the middle term. I'll write my equation as it is, 2x squared minus 5x plus 3. I need to split this middle part. That's the reason we have chosen these two numbers, so that I can split it. Minus 5x can be written in terms of minus 2x minus 3x plus 3. Now what I need to do? I need to make pairs starting to ending to. Just like this, we have to make pair. Now the question arises, what if I'll write minus 3x here and minus 2x there? It will give you the same answer. You will not find any difference in the case. You can arrange in any order. Don't worry on that part. So when I make the first pair, I have to take out something common. Clearly 2x I can see is common. I'll take out 2x as common. Whatever I'm taking out as common, I need to divide it both the numbers. Because 2x squared minus 2x, I have taken out 2x as common. That's why I need to divide 2x. I need to divide 2x. Whatever I'm taking out as common, I need to divide that number with both the numbers. So 2x squared divided by 2x is x, and 2x over 2x is minus 1. Now from minus 3x plus 3, what I can take out as common? Minus 3. Question is why I haven't taken out plus 3 as common? I could have. But if I take out plus 3 as common, my answer will be minus x plus 1. I want my second bracket to look similar to my first bracket. Then only the factorization is possible. When I take out minus 3 as common, remaining is x, because what I'm doing? Minus 3x plus 3, and I have taken out minus 3 as common. So minus 3, minus 3. Minus 3x over minus 3 is plus x, and 3 over minus 3 is minus 1. So inside the bracket, it's x minus 1. The two brackets to be same. So from here, I can take out x minus 1 as common. Whatever we take out as common, we need to divide it. Since x minus 1 we have taken out as common from 2x minus 1. So 2x, x minus 1, remaining is 2x, and minus 3x minus 1. From here we have taken out x as common. So x minus 1 minus 3. Or simply what you have to keep in mind that 2x times x minus 1, if I take out x minus 1 as common, remaining is 2x and minus 3. So these two are my factors. Once you have the factors, you have to do the same thing because it's equals to 0. That means either of the factor or both are 0. That's why their product is 0. So x minus 1 is equals to 0, which is x1 is equals to 1. And 2x minus 3 is equals to 0, which is x2 is equals to 3 by 2. You can keep it as in fractional form or you can keep it as in. So that's it for today. We have other methods as well, obviously, just like I have described in the beginning, but that we will complete in the next lecture. If you want to book online classes, you can email at akzsiacademy@gmail.com, and every link is in the description box. You can mail us, we can book the slots. And if you want to purchase the recorded sessions and if you want to access the free study material, you will find that in Akzsi app, and that is also mentioned in the description box. So that's it for today. Thank you. Stay tuned.